Okay, so yesterday what we have done is we have deployed the model to a web service. Okay, we use this and then we use the compute type as Azure Container Service, container instance, and then we have deployed. Now, in order to use that, what we need to do is we need to go to the endpoints. So, which can be found on in the machine learning studio. There is something called endpoints under assets. So if I click on that, then um, if your service ran correctly, you under real time endpoints, you can see um, one endpoint with the name that you have given. I have given, I think, AML DEP because I was deploying it. So AML DEP is my web service, and this is the endpoint. This is where I can access the endpoint. So click on that, and here you can see all the details of the endpoint and the model ID and things like that. Now we want to test, right? So in order for us to test, you can just go into test, and you can see input data to test. So here you can either change it here. So I can say and 1, and let's say let's predict um, as of 2023 season, let's say 3 or something, and it's not a holiday, and it's a weekday, and it's a working day, and these ones I'm not sure what we need to give. Let's give it whatever was specified here. So weekday, working day, whether it is 2.3.3.3.3. Everything else is point 0.3. Okay, let's go to, and let's change it to 3.3. Make sure you don't delete any commas. So point 0.3, and wind speed is also point 0.3. Okay, doesn't look like there are any errors. So next step is, what do we need to do? We need to go and test it. So with our data, so that means it is the January 1st, 2023, the number of bikes that can be rented is 267, as opposed to the screenshot of what were they showing? I think they were showing 444, looks like something like that, right? Yeah, they were showing 444. So um, so they have given 1, 2. Okay, season 2. I think we also gave season 2, but
Yeah, year
the
is
year made a difference.
2022.
Yeah, yeah, year is 2022. Year made a difference. And
What
global
about
parameters,
global
global,
parameters?
yeah, global parameters 1. Let's go and check that. Okay, maybe global parameters might make a difference. Let's see. Again, test. So this is easy to test. Yeah, this didn't change. So if I change okay, mine is season 3. Okay, if I give season 2, maybe that might change. So it's easy to test it. Okay, even then it's not. 2. Maybe our model is, yeah, it's a little bit up, 30306. Okay, so that's how you can test. Okay. Uh, okay, what's happening? Okay, so I will increase a bit. I can't see it. Okay, 90, 80%. Okay. So now we have tested the results. Now we need to clean up, right? So how do we clean up? Can anyone tell me? Unmute and tell, please. I don't know. I forgot how to clean up. How to clean up. No? Okay, first we had a subscription, right?
Go to resource group.
Yes, go to the resource group. Yeah, this is the resource group. And in the resource group, you can see everything, including the Azure Machine Learning Workspace, right? So AML AI 900 WS, that's what I have given. So here, if you go inside that resource group that you have created, click on delete resource. And what it's going to ask is it's going to prompt you for entering your resource group name. So I'll just copy this one and then paste it. Here pasting is Control V and not Control Shift V. And then delete, and it's going to ask for confirmation. Yes, I don't want to use this anymore. Yes, I've deleted. Have you all understood this one? Okay, that's good. Okay. Now that I think that concludes the yesterday's session. Now let's move on to today's one, module 3. Anyone remember what that is?
Vision.
Yeah, computer vision. What is computer vision? And we will have a look at what is computer vision, um, and maybe we can do a exercise on computer vision as well. So now let's start off with computer vision concepts. So first lesson is computer vision concepts. Okay, what is computer vision? Can anyone tell me? Unmute and let me know, please. Computer vision. Just maybe translate that. Can anyone do it or shall I do it? Okay, looks like everyone is sleepy. Okay, computer vision is computers can see. Okay, literal translation is computers can see, but how do they see? They see the world through digital images. So this is an image, this is through digital images, and these digital images can be in the form of just photographs or live feed cameras. Here there is a camera, or recorded videos. This is the recorded videos. This indicates recorded videos. And these are how computers see these images and videos and what do you call, and the recorded videos and the camera feeds is in the form of what is called a pixel. So for this is a traffic image, right? So each digital image is actually an array of numeric values. It can be 0, 1, like that. And the numeric value will indicate the color intensity of each pixel in your image. Okay. Now you can use these values just like any other data as features. So you can use these as features. Now you are familiar with the word features, right? And these features can be used to train a machine learning model or to apply some transformations and calculations to analyze the image. So for example, if what do you mean by analyze the image? If I analyze this image, what I will see is, because I am a human, I can say two people biking, and there are three trees, and there is a big van, and big truck, and there is a car, and there are arrows going towards left side. So those that is called image analysis. So that kind of analysis can be done by the computers based on these features. So that's the capacity of the computers. So what do I mean by these features? So how the computers see the image is this kind of pixelated, these kind of numbers. So these are the numbers stored in the computer when they see this particular image. Now The number can be from 0 to 255. So that is the range of the numbers. And each the range represents the intensity of each pixel. So each color, in the case of color images, they are three types of pixel values. One is for any, can anyone tell me why there are three types of pixel values?
Mm.
What are our primary colors? How many do we have?
Oh,
Red,
three.
green, blue. Yes, what are they? What are our primary colors? Chat GPT.
Oh,
RGB,
RGB. Pink.
Yes, RGB, red, green, and blue intensities. So that's how they store. So one is red, one is, see, this is a grid. There are three grids: red, green, and blue. So that's how they store, and that's how um, they can see that this is colored, this is not colored, this is a bit, the color intensity is this much, so that is red. That kind of stuff. The computers doesn't know which one is red, which one is green, which one is blue, but they understand in terms of numbers between 0 to 255. Got it? Or as clear as mud?
Mhm.
Okay, so that is what is computer vision. Now, let's go to what are the applications of computer vision? Can anyone tell me a few if you have seen? What is happening these days? If you upload a picture on your Facebook or Instagram, what happens these days? It prompts you with something, right? What does it prompt? I'm just trying to make you think, okay? What happens? Does it ask you to tag your friends sometimes? Or does it say that is this person?
Mm.
Yes, perfect. Yeah, facial recognition is one form of computer vision. So let's see what are the applications of computer vision. So image classification. Computer vision, you can train and then you can create an image classification model. And so how does the image classification model work? Now we have understood that computer vision stores in the form of numbers, right? So that numeric pixel features then is used to predict a class label. So classification, you learned about classification in yesterday's types of machine learning, right? So that is supervised or unsupervised? I forgot. So supervised or unsupervised?
supervised,
Yes, perfect. Okay. So it is a supervised machine learning. Um, so then the classification based on the numeric pixel features, it will predict a class. So for example, this image classification, this image, what is this image? This is a taxi in USA. There are yellow colored taxis. So this has been classified by the computer vision as a taxi. Okay. So that's one application of computer vision. The next one is object detection. In the earlier picture that we saw, remember we were talking about cyclists. So this will detect the objects saying these two are cyclists. This is a bus. I thought that it was a truck, but this is a bus. And this is a car. And if the computer vision was trained enough, it could have detected even the trees. Okay. And also the left arrows and things like that. So that's what is called object detection. So the computer vision is applicable. One of the applications of computer vision is object detection. Okay. Now, next one is semantic segmentation. What does that mean? Can anyone tell me? Okay, so what I mean by semantic segmentation is it's an advanced kind of model that classifies individual pixels into images where the objects belong. So bus is red, okay, car is blue, the original car is white, right? But it has segmented it and then colored it as this one is car, okay, and cyclists are colored as green. So that's what it has done as a segmentation. And is there a label here?
No.
No, only pixelated features, right? So that means this will come under
Like unsupervised learning.
unsupervised. Yes,
Unsupervised?
perfect. Yes, perfect. Very good. Yeah, you are all with me. I'm very happy that you are understanding. Okay. So that is what is called segmentation. It's something similar to clustering, but the word is used as semantic segmentation. Okay. Now, next application is image analysis, like how I was talking about. Cyclists are going in the going forward, and there is a car going forward beside a bus which is a bit behind, something like that. That is called an analysis. What here, this image, it analyzed, the computer vision analyzed, and then it said a person with a dog on a street, because that is the dominating part in this image. So that's why it said that it analyzed this image and it said that a person with a dog on a street. Okay. So another application is like how you have said, face detection and recognition. If the computer knows, for example, if you are a celebrity, Satya Nadella, if there is a photo of Satya Nadella here, the image will analyze and say Satya Nadella is walking on the street or something like that. So here what it is doing is these square boxes are, it is detecting the face, and once the face is detected it tries to recognize as well, based on the celebrities, or based on what it knows, computer vision knows. Okay. So that is um, face detection and recognition. And next one is optical character recognition. Can anyone tell me, anyone guess what optical character recognition is from this one? What is this and how did it get this?
Characters on the
Yes, on the image. Yeah, if there are if there is any text in the image, it will get that, and then it will say that this is the text that is there in this image. So this has the Toronto Dominion Bank. So that's what it has identified. So that is what is called OCR. OCR means optical character recognition. So will you remember now? What are the applications? There are six: image classification,
Yeah.
image analysis, object detection, face detection and recognition, semantic segmentation, and optical character recognition. Because you might get some questions from this. You will get, not you might, you will get. Okay, let's proceed to the next one. Okay, now computer vision services. There are four of them, like how we saw four Azure ML services, right? Azure AI services in the last class. Now we will be uh, looking at what are the services, computer vision services in Azure. So one is computer vision, which we have all seen now. Image analysis, common object detection, face detection, semantic segmentation, smart cropping as well, and then optical character recognition. Now, the next one is custom vision. Computer vision is already trained. We can't train anymore. That is what is called computer vision. It has been trained by Microsoft and is available as a service for us. But custom vision, what it means is you can classify, you can upload some images and classify, you can train them, like how we have done in Azure machine learning. We have 100 rows and we are training 70 rows, and then we are testing 30 rows, or we are training 80 rows and we are testing 20 rows. like that, we can upload some images. We can upload 100 images of different variety, like for example bananas, apples, oranges, guavas. So you upload four kinds of images and train them, and minimum training sample is I think 5. If you upload 5 images and train in a into a custom vision model, then what you can do is you can test the other forms of images, and then it will recognize saying this is a banana. I'm sure that this is a banana. 85% I'm accurate. It will give you the percentage as well, how much accurate that is, or 90% accurate, depending on the image clarity. Okay, so that's what is custom vision. So with custom vision there are two things that are possible. One is image classification, and the other one is object detection. So there are two um, kinds of services that are available that we can use from custom vision. Next one is face detection and analysis. So analysis means here you can train, this is Indira, this is Siri, this is Stefan, this is Jane. So you can upload 5 images of yourself, each one of the group, and then once you train, then it will detect the face and then analyze as well. Okay, this was Jane, that I was trained, and I'm sure that this is Jane 85%. I'm sure that this is Jane only 65%, depending on the quality of images that you have used for training. So that's the kind of face service that we have in Azure. And then we have form recognizer. Form recognizer is it incorporates the use of optical character recognition, because you have a form, right? So in the form, if you have a set of, like for example, invoices, what you do is you upload the invoices and train the model, saying that this part is my form and this part is my input. So for example, name, you have a form where it says name, um, street, country, things like that. So those name, street, country, you can mark them it's called value pairs, key value pairs. That those are the keys, and values are name Indira. Indira will be the value, name will be the key. So that kind of training, if you have done, if you do, then you can extract the forms, extract the data out of out of those forms in the from the invoices, and then that they can straight away go into your database. You don't have to sit and these type this data manually, but you can just scan those forms, and then the computer will do it for you. That is
Session
what is called form
AI
recognition service.
AY0C15 RDLV36 app 9WM Works Re XS6 NQ model.
Thank you. Okay, so ha- uh, so what are the vision services now? You need to remember. One is computer vision, the other one is custom vision, and face service, and form recognizer. Okay, so okay, so remember that. Now lesson 2 is let's creating computer vision solutions in Azure. Let's see what that is. So image analysis, what it does is, with the computer vision service, what it does is pre-trained computer vision model. So because as I have mentioned, um, Microsoft has already pre-trained the computer vision service, so we can just upload, and then you can just have a service. You use the service. What does this service do? It detects the objects. If it is a man, or a, see, it says male person 34. It sometimes predicts the age as well. Okay, and there is jeans, footwear, and there is footwear. So it tries to analyze, detects the objects, and then it gives you a description of the image, and and also tags. Sometimes it tags as well. And yeah, you can detect the face detection and analysis as well in the computer vision, which we have seen. And then sometimes it does content moderation. What does content moderation mean? Can anyone tell me? Yes. Okay, content moderation. See here, ratings, whether the content is only for adults or racy or go. So these three are the ratings for content moderation. Is it adult viewing only? It's false. Racy, false. Gore, false. So these are the three things that it will do for content moderation. And if there is any text here, it's going to detect that, and then text detection of text, and then gives what that text is. Optical character recognition also happens. So this is the whole thing about, this is what happens in the computer vision service. But it is pre-trained. Just remember that it is pre-trained, because custom vision is not pre-trained. We can train. So we can use whatever we want to train against, we can use. So that's what it is. See, training models with the custom vision service. We can train our own images. So image classification. And there are two services that are available from custom vision. One is image classification, the other one is object detection. So this is, we train a few um, apple images, few banana images, and few orange images. And then the next set of test, what it does is it will identify whether it's an apple or a orange or a banana. That is what is called image classification. And object detection is, if you have all these in a single image, what it does is it detects, and it forms a square. What object detection is nothing but it forms a square, and this is a banana, and that is an orange, and that is a apple. So that kind of object detection is possible with custom vision, not with computer vision. Okay, so that's custom vision. Now next one is detecting faces with the face service. So anyone can use the face service to detect um, blur or blur, exposure, glasses, head pose, noise, occlusion. All these can be uh, can be detected with the face service. And and this is only managed for only managed Microsoft customers. So that means I think there is some kind of a charge there, and only managed Microsoft customers can access facial recognition capabilities. So similarity matching and identity verification. So these also can be uh, used. Now to support Microsoft's responsible AI principles. Responsible AI principles. We heard somewhere, right? Where did we hear that? And what are those principles? Can anyone tell me? Did we hear that or did we forget?
Transparency, inclusiveness,
Very good. Yeah. We have how many principles did we have?
Non-biased.
Yes, fair. That is called fairness.
fairness.
Yeah.
Yeah,
Yeah. Three more.
I think there were five of them.
No, no, there are six, I think. Let's see.
Right. Yeah.
Fairness is the first one. The next one is
Transparency.
transparency. Yeah. Transparency. Somebody else said that. Oh, you are typing it. Sorry, I didn't save it. Okay, reliability and safety.
Inclusiveness,
Yeah,
security,
inclusiveness, reliability and safety, and privacy and security. Yes, Harisudha. Yeah, privacy and security. And
Transparency and accountability.
very good. Yes, we got all of them. Well done. Okay, that's good. Okay, now to support Microsoft's responsible AI principles, facial recognition is under a limited access policy. that because you can do anything with the face recognition, right? That's why there it's under a limited access policy from Azure. So just remember that. You might have to apply for access or something like that. Okay. Now, reading text with computer vision service. What is it called? Reading text. It's called text recognition. Okay. And OCR, optical character recognition, detecting the location of text. So this is the location of text. I just uploaded this particular photo, which was there maybe on my fridge shopping list. And then what it does is first it actually blocks off, like identifies where is the location of the text, whether it is printed or handwritten. And then options for quick text extraction from images. So this one is really easy, really clear. The writing is really clear. So it has detected, and then it is the result is showing here. Shopping list, non-fat milk, bread, eggs. Easy, right? So that is the reading text service as well with the computer vision. Now, analyzing forms, which we talked about. This is the receipt of me buying an apple and an orange. Okay. So what it does is it extracts the information from scanned forms in image or PDF form, and then uses the pre-trained models for common document types. So for PDF document type, it uses the pre-trained models. If this was, I think there are a couple of, I think there are 4 or 5 forms that are already pre-trained by Microsoft, and that includes these kind of invoices. I mean, this kind of receipts and invoices, as far as I'm aware. And then you can also train a custom model using your own forms. So that also is possible. So those are the 2 things that are possible with form recognizer service. And models perform semantic recognition and of form fields, not just text extraction. So here it just extracts a text, right? But in a form, what you have is you have name, like how I explained, name and key value pairs. So it will pair them so that with the keys you can make them as fields and then field values. So that's what it is. Okay, now we have computer vision lab. Would you like a break? And then we can come back and continue with the yes, no, yes. Okay, let's do it. Okay, let's do it for 9:45. 10 o'clock we will start. Okay, 15-minute break. I think I'll stop the recording and then we can